Hi there, Richard here at the RPS project. I'm going to have another look at resistors in parallel. Last time I had a look and just calculated what the total resistance would be if I had more than one resistor in parallel. So I'm going to add a little extra to that and actually put a voltage across a couple of resistors in parallel and see what readings we get. Okay, well, have a look at that. First, time for a brew. Okay, here we are. Let's have a look at a couple of resistors in parallel and what the voltage and current's going to be for these two. I've randomly chosen 220 ohm, 760. So the first thing to do is go, well, okay, what is the total resistance? And that was our total, of course, R1 times by R2 divided by R1 plus R2. So, very simple, we've got 760 ohm, R1, 760 ohm, R2, what do I do? 220 ohm. So let's plug that in. So that's 760 times by 220 divided by 760 plus 220, and doing that nice and quickly on my calculator. I do apologise for the lighting, I still haven't got it sorted out and the lighting around here is rubbish. Never mind. So turn it on, bracket 760 times by 220, close bracket, divided by bracket 760 plus 220 gives me 171 equals 171 ohms as a total resistance. So what's my current going to be? Back to good old Ohm's law. V over I times R. Now what we want here is the current, I. So I equals V divided by R. We have 12 volts divided by 171. 12 divided by 171 gives me 0.070 amps. That's 70 milliamps. Straightforward, eh? So there you go. I suppose what's the total power that this thing's going to deal with? We've got a voltage and a current. So power is current times voltage. So I know the current is 0.07 amps by the 12 volts. I'm dumping through the whole lot. So 12 volts I'm putting across the resistance. So 0.07 times by 12 equals 0.84 watts. That imagine that get quite warm, really. So I suppose, what's the individual current through each resistor? I suppose that's one thing I didn't look at. What would that be? Does it matter? So that's quite simple. That is literally just the basic Ohm's law, isn't it? That's 12 volts divided by 760. This is a current, and on the other one we have the current equals 12 volts divided by 220 ohms. Let's have a look at that. 12 divided by 760, 0.015 we'll call it, and 12 divided by 220, 0.055 I'm going to go with. Now if I add those two up, that's 0.015 plus 0.055. What am I going to get? This is my current. 0.015 plus 0.055 equals 0.07. Where was that other calculation? $70 milliamps. 70 milliamps. Exactly what I've got. Now, that means that you can calculate the current between the two, between each individual one, and just add them together, or calculate the total current, and then there you go. Calculate the total resistance, and then work out the current. Either way will actually work. Now, I was going to make this up on the breadboard, but if I do that with these two resistors, that's nearly a watt in power. You know, it's going to get quite warm. Where do I do that? There. Put 8.4. So actually I'm going to use some slightly larger resistors. On this side I'm going to use a 2K2, and I've got a 7K5 resistor. So let's quickly do the calculations on that. So 7,500 times by 200 plus. So I end up with a total resistance of, let's call that 1K7. Right, so I've got 12 volts divided by 1,700. So my current equals 0.007. That's 7 milliamps. Marvellous, because if I've got 7 milliamps times by 12, my power equals 0.084 watts. That is 84 milliwatts. That's brilliant. That'll certainly cope with that. So yeah, so I mean that's pretty darn simple. So let's get that bit of a circuit on here. Just move it out of the way. So let's see if I can get this all in. Do it like that. I've got my 2K2 and my 7K5 in here, and I've got the multimeter, which hopefully should show me the amount of current that's going to be going into the circuit, and then I'll get my other multimeter and have a look at the total resistance. So before I turn it on, total resistance, so what did I say? I've got to just take this out and have a quick look. So that one is my $7K5, and this one is $2K2. Put them together in series, in parallel, and I will end up with 1K7. Brilliant. So if I now turn on the get this multimeter turned on and put some power into it. Yeah, helps if I turn it on at the mains. Classic mistake that. Turn it on at the switch. Hey, done. There you go. 7.15 milliamps, which is exactly what I calculated there. So there you go. And just to prove I've got my 12 volts, turn that round to volts, which is around that. There you go, 12 volts. There's not much more I can say about that, is it? Resistors in parallel. We've had a quick look at an actual little circuit with current flowing through it. It is simple. Both resistors in parallel and resistors in series, but it is a fundamental, so it is something to know. And even though it seems so simple, you can find yourself getting caught out on circuits where you've not bothered to calculate it properly, and then realise, hang on a minute, if I go back and look at that particular part of the circuit and find out you've made a classic beginner's error, I suppose, and got it all wrong, and that's why your circuit might not work. So there you go. So there you go. Resistors in parallel. What more can I say about it? Quite simple, really. So if you happen to like the video, give us a like and subscribe, then I can make more videos. Catch you next time.